Good day, everyone. Well, actually, I have this sort of cutoff that if more than 10% of you request me to record a certain extra material, then I do it. This topic was requested by fewer than 10% of you, but still I decided to do it nevertheless because it is an important topic and I saw that it caused some difficulty in class, so let me do it. Alright, so here we have the logistic equation. So it models population of fish in a certain lake. So let me write down the logistic equation. So we know that y prime equals growth rate 0.5 ton per year. So it means that y prime equals 0.5y times 1 minus y divided by the carrying capacity. The carrying capacity is 175 tons. And so this is our logistic differential equation. And then we have this initial condition. The initial condition tells us that y of 0 is 10. Alright, so let me first of all review some facts about the logistic differential equation. So it has two solutions, two equilibrium solutions, y0 and y equals 175. So they're equilibrium solutions. What is important about equilibrium solutions is that if you plot the direction field of the logistic differential equation, then you will see that solutions with initial condition between the equilibrium solutions, they of course cannot cross equilibrium solutions, cannot get out. So which means that what we definitely know is that for all values of t, our y is going to be between 0 and 175. Okay, now let us solve it. This is a separable differential equation, so to separate it we divide everything by y, then the left hand side becomes dy divided by y times 1 minus y over 175, and the right hand side is 0.5t. Then we write the integral sign, so we have to integrate. Well, integrating 0.5t is easy. It's just sorry, that was dt, of course. Dt. This is 0.5t plus constant. How do we integrate the left hand side? So the left hand side is a rational function. So to integrate a rational function, we need to express it as a sum of partial fractions. So we need to write that this is the sum of something, some constant over y, plus some constant over 1 minus y over 175. So how do we find these constants? Well, first notice that whatever this constant times 1 is going to get us the one that is here. Well, but then it means that since we have 1 here, it means that I must write 1 here too. Okay, so then imagine that after we multiply 1 times 1 minus y over 175, here we're going to have 1 minus 1 over 175, and in order to compensate, I need to multiply by 1 over 175 here. Okay, so then I think it's correct. Yeah, so if you just verify my calculation by adding these two fractions, you will see that it is correct. So dy, this equals to, let me rewrite it a little bit, as dy over y plus integral of dy over, I'm going to multiply by 175, so 175 minus y. Alright, and then strictly speaking, the antiderivative of 1 over y is a ln of absolute value of y, but since y is positive, I'm going to write just ln of y. then the antiderivative of 1 over 175 minus y is again ln of the absolute value, but since y is less than 175, I'll just write it without the absolute value, since 175 minus y is positive. Well, and this is of course ln of y over 175 minus y. Okay, good. The next step is to use the initial condition to find the value of c. So how do we do that? Now the left hand side, well, this is the left hand side of the resulting equation, and this is the right hand side. Right? So this is an equation in y. So we need to solve it for y, but first we need to find c. The initial value of y is 10. So the left hand side becomes ln of 10 over 175 minus 10 is 165 equals 0.5. 0.5 t is just 0, is our constant, I guess. So that's our constant. Our constant is ln of the ln of 10 over 165. Okay, so let me write the final equation. So our equation is ln of y over 175 minus y equals 0.5t plus ln of 10 over 165. So how do we solve it? Well, we just apply the exponential function to it. The left hand side becomes e to the power ln of anything is that same expression, so is y over 175 minus y equals e to the power 0.5t. Well, when we apply exponential function, plus becomes times, and e to the power ln of something is just is 10 over 165. So now we need to solve it for y. So how do we do that? So first let's multiply by 175 minus y. So 1y equals 10 over 165 times e to the power 0.5t times 175 minus y. So the next step is to move y to the left hand side, grouping all the terms with y together. So then we have y. The original coefficient was 1, plus the coefficient that comes from the right hand side, plus 10 65 to the power 0.5t equals, well, 1750 over 165 e to the power 0. Okay, great. So the final answer is 1750 to the power 0.5t over 165, and everything divided by 1 plus 10 over 165 to the 0.5t. Okay, beautiful. So let us simplify it. How do we simplify it? The easiest thing to do is to multiply by 165. 165. Okay, then probably we can cancel by 10, I guess. So we can delete 10, divide by 0, and here we're going to have 16.5. And then we can divide by e to the power 0.5t. So then it's going to disappear here. It's going to disappear here, and it's going to appear here, e to the minus 0.5t plus 1. Okay, so this is the final answer. Let me rewrite it somewhere here. So y equals 175 divided by 16.5 to the power minus 0.5t plus 1. Well, this is the solution of this particular initial value problem. But the question is kind of is more than that, right? So it's not just to solve the initial value problem, but also to find some further information about it, right? So we need to find when the population is going to reach 90% of its carrying capacity, right? So what is it? So it means that the population, we need to find the value of t such that this y of t equals 90% of the carrying capacity. So in other words, we need to write down, this is our solution, 175 over 16.5 e to the power minus 0.5 t plus 1. This should be equal to 90% of the carrying capacity, which is 0.9 times 175. Right, and the question is to find the value of t. So in other words, now t is the subject, and we need to solve it for t. Okay, let's do it. I guess the first we probably just cancel by 175. Right, so then what are we going to get is 1 equals multiplying by the denominator, and we get 0.9 times 16.5 to the power minus 0.5 t plus 0.9. So 0.9 times 16.5 e to the minus 0.5 t equals 0.1. Yeah, I guess we can 2 times 10. So multiplying by e to the 0.5 t, we get e to the 0.5 t equals 9 times 16.5. So 0.5 t equals logarithm of this, 9 times 16.5, and t itself is 2 ln 9 times 16.5. I hope I haven't made any mistakes, but if I have, then sorry, please let me know. I will